Siri, what is artificial intelligence?
Here is what I found.
Well, it looked it up for me. So we actually interact with artificial intelligence on a daily basis, and a lot of people might not realize it. And also, it's also the second major revolution of the 20th and 21st century. So the first revolution was the Industrial Revolution, which changed how we use our muscles. So now we have machines to replace muscles. But this revolution is different in the sense that we're going to be replacing our minds now with these machines. And a lot of people don't realize how fast it's coming up on us, and the majority of people are either scared of it or don't understand it because the media tends to sensationalize these things. So today I'm going to teach you about neural networks, which is the driving force of artificial intelligence today. So a little about me. I actually am a software engineer in the field of artificial intelligence, and I've worked for companies and been recruited by companies such as NVIDIA, Cruise Automation, Leapmotion, Monosdrive, etc. I've done work on biometric data, natural language, so like text generation, human speech, and I've also kind of famous on the internet for my work with self-driving cars. So, what is a neural network? Well, it is basically a black box. And what I mean by black box is you put in an input, so let's say some words or some text or some numbers, and it does something random and completely opaque to you. So you don't know what it's doing, but it just outputs something else, right? So it's an input with a bunch of random, and then it goes to a bunch of random messes, and then it outputs some random numbers. So this is just a visual representation of this. I know I don't expect anyone to really get anything from this, but I wanted to put this up to show you what it looks like conceptually. So basically the yellow here are inputs, and the blue here is just a big mess that we don't really understand. And then the orange is an output, right? So here are there's a bunch of different kinds of these neural networks, and I just want to show you the variety that we have here. It would probably take me an academic quarter to explain all of these, but we don't have to worry about it. So you might be wondering how literal random math and just this huge chaotic system could possibly output anything intelligent whatsoever. So we're going to learn how these neural networks learn in the first place. So we teach artificial intelligence through several methods. The first one is called supervised learning. So what we do is we take examples, right? So for example, let's say we're trying to teach a neural network to recognize images. So we'll give it a bunch of images as inputs and tell it what the image actually is, and we compare it to the random output we get. So we get a random output from this neural network, and we say, how wrong is it? So if it predicts the image as something incorrect, we tell the network it's wrong, and we adjust this random math that goes on the inside. So I know it's a little abstract right now, so we're going to do a very quick example on the board. I promise you this will not be very math intensive, but I want to show you how this kind of random guess and check process actually works. So I'm going to just put a math problem up here, and some of you might know how to solve it right off the bat. So we're going to say 5 times something is 14, right? This is a pretty easy problem, but let's say I didn't know how to do division, so I can't solve this right now. I'm going to pick a random number, so let's say 10. And let's see what this gives us. This gives us 50, right? Which is pretty far off from 14. But we know it's bigger than 14. So that means that we know the answer must be less than 10. So let's decrease this answer. I'm going to change it to 5. And now we get 25, still bigger than 14. So let's decrease it even more. Now I'm going to do 2. Now we have 10. 10 is less than 14. So we should probably make this number bigger. So now we're going to go up to 3. And we get 15, and so on. So now you can just narrow your prediction. You can keep guessing numbers that are closer and closer until you actually get to the actual value, which is 2.8. So through this method of kind of guessing and checking, we can train a big mathematical system to guess the right answers on the first try. There's also something called unsupervised learning, which is kind of unintuitive at first because you give a neural network information without any context whatsoever. You don't tell it what's right or wrong. and somehow it learns from that. This is actually a very advanced statistical concept where these networks can discover patterns from data. So, for example, if I give you a bunch of red balls and a bunch of blue balls, you can kind of sort them yourself, and you know that they kind of categorize on themselves. Even if you don't know what these objects are or why you have them, you can kind of sort them. So an example would be the following. If I give you a bunch of pictures of horses and a bunch of pictures of zebras, can you learn how to Photoshop a horse into a zebra? Well, it turns out neural networks can. So what we gave this network is a bunch of pictures of horses and a bunch of unlabeled pictures of zebras, and we told them that we want to transform one image into the other. And through this mathematical process on the board, we were able to teach a network to actively Photoshop it. So this is the image it was given, and this is the image that it outputs, right? So these are totally fake images, and they're all generative. So these kinds of models are called generative networks. Another example is we can give it a painting and say we want to transform an image in the style of painting. This is called style transfer. So we give an original photo like a cityscape, and then we give an example, such as the city at night, and we merge them together. So I did this with myself, and this is a painting by Van Gogh, and then a picture of me, and this is the result that came out. So that's kind of interesting. So there are several types of neural networks. The major ones are convolutional, which is image-based. This was actually originally invented by Jan LeCun in one of his papers. There's recurrent, which is time-based, and then there's generative, which is what I just showed you. And there's many, many, many more that I don't have time to go over right now because I'm running short. Okay, so I'm going to show you a real-life example that I wrote up a few nights ago for the purpose of this presentation. So just to show you how this works, I'm going to actually run an example right now. So what I'm doing right now is I'm training this computer to recognize handwritten digits through a data set of images that are labeled as such. So basically, I gave this computer a bunch of images of numbers, and I told them which images were which. So now, hopefully, if I draw a 3, it'll classify it as a 3. And if I draw a 1, this isn't extremely reliable, so yeah, it'll classify it as a 1 and so on. So I hope that this helped increase your general understanding of artificial intelligence. Might have been a little confusing, but this is confusing for everyone in the field.